left off on Friday, since we had a short class, we were doing determinants. We still have in this section finding the area of a triangle with the given vertices, and then also applying Cramer's rule. So 22, to find the area of a triangle, they give us the different vertices. So the point A is at 1, 5, B is at 4, 6, and C is at 7, 3. So in your notes, just as a refresher, because obviously that would have been a little while ago, you had area is equal to plus or minus 1/2, and it's plus or minus depending on what your determinant value ends up being, because area has to be positive, right? So that's why it could be negative, could be positive, just depending. And then it's the determinant of x1, y1, 1, x2, y2, 1, and x3, y3, 1. So it makes a 3 by 3 matrix that we're taking the determinant of to find this. So we have area is equal to, I don't know yet if it's going to be plus or minus, so I usually just start out by writing both. And then we have the determinant. So instead of putting like the matrix bars, if we're taking the determinant of the values, we usually just do essentially like absolute value bars that are just like ginormous. Or like that's how I think about them, but it just means to find the determinant. So it would be 1, 5, 1, 4, 6, 1, and 7, 3, 1. I'm going to do this one by hand just so that we have a refresher on how to do that. So I'm going to just remember that this is out here right now. I'm just going to find the determinant. So it's 1 times the determinant of all of this stuff right here. So it's 1 times 6 times 1 is 6. And then 3 times 1 is 3. So 6 minus 3. Minus 5 times the outer ones. So 4 times 1 is 4, minus 7 times 1 is 7, and then plus 1 times this stuff over here. So I've got 4 times 3 is 12, minus 7 times 6 is 42. So I've got 3, and then I've got, this is negative 3. Negative 5 times negative 3 is positive 15, and then 1 times negative 30 is just negative 30. So that means that this value is negative 12. So it needs to be multiplied by negative 1/2 in order to become positive. And obviously then my area would just be 6. Now, not necessarily the most efficient way to find the area of a triangle, obviously depending on what you're given, but it's a way that if you're just giving coordinates that you can find your area of your triangle. Do we need to see another one of those, or are we okay? Awesome. All right, Cramer's rule. So this is definitely like kind of a weird way to go about solving a system of linear equations. It's not necessarily my go-to, but it does make it easier in a lot of senses to do this. So, and we're only going to do the ones that are 2 equations, 2 unknowns. There are some 3 equations, 3 unknowns in here. There's another method entirely that I was talking about when we were doing 3.4, when I was like, oh, you'll have a calculator way that'll make this so much faster. That's in 3.8. So 30, we have 2x minus y equals negative 2, and we have x plus 2y equals 14. So the very first thing that I need to do is I need to find what we call our coefficient matrix. And so that's the numbers that are in front of the variables. So that matrix, I'm just going to call it matrix A, is going to be 2, -1, 1, 2. So it's the numbers in front of the x and y values. And I need to find the determinant of this. So the determinant of A would be what? Or how would I find it? Yep. So 2 and 2 is 4, and then minus a -1, so +1 is 5. So that's going to be the denominator in Cramer's rule. Okay. So to find x, we take the determinant of, we have our x values get replaced with the answers. Okay. So -2 and 14 will go where the x value should have been. This would have been the x column of this matrix. The y column is the numbers that are in front of here, so -1 and 2. And then we put all of that over the determinant of our coefficient matrix, which was 5. And this is going to find the x coordinate of our system. So the determinant of the top, -2 and 2, that's -4, minus a -14 would be +14.
Oh, so it's 2.
And then over 5, so 10 over 5, so yes, 2. So that's our x coordinate of, like, our solution.
We can find y with that.
So we just plug
Using Cramer's rule. So no. So then y, to find it, we take, whoa, I made that really large. We take the x values and we copy them down, so 2 and 1 in that column. In the y column, we're replacing that with the answers, so -2 and 14. And then over the determinant of 5. So 2 and 14 is 28, minus a -2, so that'd be +2, over 5, 30 over 5, which is 6. So the solution is still an ordered pair, so make sure you don't do everything and forget to write it as an ordered pair, would be 2, 6.
Don't you also just find y like?
Whoa.
Yes, but it says use Cramer's rule.
Can you pay attention?
So that's what you're going to have to watch for when you get to the test for this stuff, is that it's going to, like, you're going to really have to watch, am I using just solving it? Am I using Cramer's rule? Or are you using the other option that I've allowed you to use? Now, you can check by any of the other methods, but you have to show it the way that it says in the instructions. Do we want to see another one of these?
Yes.
Okay. All right, I'm going to do an odd one because the rest of them are 3 equations and 3 unknowns that are even. So 31. 5x plus y, what did I say plus 5 is y, equals -40. And 2x minus 5y equals 11. So I need my coefficient matrix first. So that's 5, 1, 2, -5. And I need the determinant of that, which would be what? Or how would I find it? So 5 and -5 is -25, minus 2 and 1 is 2, so that would be -27. So that's the bottom of the denominator. Now, I usually just start with x because why not? However, you don't have to. You can start with y if you really wanted to. All right, so to find x, how would I set up the top for the determinant here?
40, -40 and 11. Wait, no, -40 and 1?
You got this.
Going this way?
Yeah.
Okay, yep.
And then 11 and -5. Right?
Yep.
Wow.
And then all over -27.
I was congratulating.
So then negative 40 and negative 5 is 200
Whoa.
minus 11 and 1 is 11 over negative 27. So what is that? 189 over negative 27. I don't feel like doing that by hand right now.
It's 7.
Yep. Negative 7.
Because the 9 would have to be 49, and sometimes 7 is 49.
So it's your x coordinate. Y, how would I set up the top?
5 and then negative 40. And then 2 and 11
Yep.
over negative 27.
So 5 and 11 is 55. Minus a negative, so it's going to be plus. 2 times 40 is 80 over negative 27. So 135 over negative 27 is negative 5, yep. So then my answer, again, is negative 7, negative 5 as an ordered pair.
Oh my goodness, I can't believe it. 3 are always to the this side.
All right, I'm going to go back up here to add on the problems that you had from the other day.
My killing, your math used to break 1
23, 27, and 29. You can do these two with your calculator if you would like to. It's the triangle ones. Just make sure you don't forget that 1/2 in the front.
Can I go grab my book?
And remember, you can't have negative area.